Reduction of reflectivity of lens surface. In this topic, we are discussing how to reduce the reflectivity of lens surface. We have the equation for reflectivity r square equal to mu1 minus mu2 divided by mu1 plus mu2 whole square. Mu1 and mu2 are the refractive indices. There are two types of glass surfaces. One is ground glass surface, another is flint glass surface. Ground glass has a refractive index 1.5 and the flint glass has a refractive index 1.67. Now, consider the first case, ground glass. Refractive index is first medium mu1. We can take air as the first medium, so mu1 equal to 1. Mu2 for ground glass, it is 1.5. Then the equation r square equal to mu1 minus mu2 divided by mu1 plus mu2 all square. That is 1 minus 1.5 divided by 1 plus 1.5 square. You will get the value 0.04 multiplying by 100. You will get 4%. That means 4% of the light is reflected in the case of a ground glass surface. 4% of the light incident on a ground glass surface is reflected. It's a major issue in the case of a formation of a lens or any optical devices. Now we have another choice, which is flint glass, which has a refractive index 1.67. Here also the first medium is air, which has a refractive index 1. Mu2 is equal to 1.67, maybe 1.62 to 1.67. It may be varying, depends on the material. Now it's 1.67. Now r square equal to 1 minus 1.67 divided by 1 plus 1.61 square. We will get a value as 0.06. Multiplying by 100, the value will be 6%. That means 6% of the light incident on a flint glass surface will be reflected. It's also a higher value. So when we are using a ground glass or a flint glass to manufacture a lens or any optical devices, there is a huge reflectivity. A considerable percentage of the light will be reflected. It's a significant issue. As the surface increases, there will be considerable loss. To reduce the loss, lens surfaces are coated with a non-reflecting film with a thickness T equal to lambda by 4 mu. Surface increase ചെയ്യുന്നതിനനുസരിച്ച് ഈ reflectivity ഇനിയും കൂടും. So നമുക്കുള്ള ഒരു solution എന്ന് പറയുന്നത് we can coat the surface with a non-reflecting material or a non-reflecting film. A non-reflecting film in a condition under the non-reflecting film has a thickness T which is equal to lambda by 4 mu f, where mu f is the refractive index of the film. Now we are taking T equal to lambda by mu f. എന്തുകൊണ്ടാണ് T equal to lambda by 4 mu f എന്നെടുത്തതെന്ന് നിങ്ങൾക്ക് ഈ ഡെറിവേഷൻ്റെ അവസാനം മനസ്സിലാവും. Lambda by mu f we can represent by a single letter lambda prime, or that is T equal to lambda prime by 4, where lambda prime is equal to lambda by mu f. So this is the non-reflecting film. T equal to lambda by mu f, lambda by mu f equal to lambda prime, that is T equal to lambda prime by 4, where lambda prime is the wavelength of light in the film. ഈ ഫിലിമിലുള്ള ലൈറ്റിന്റെ wavelength ആണ് നമ്മൾ lambda prime എന്ന് പറയുന്നത്. Now we have the equation T equal to lambda by 4 mu f. Multiply LHS and RHS of the equation by 2 mu f. So equation നമ്മൾ രണ്ട് സൈഡിലും 2 mu f കൊണ്ട് multiply. Then you will get 2 mu f into T equal to 2 mu f lambda by 4 mu f. ഇനി നമ്മൾ RHS കൺസിഡർ ചെയ്യുക. RHSൽ mu f ക്യാൻസൽ ആവും. 2 divided by 4 equal to 1 by 2. That's equal to lambda by 2. That is 2 mu f into T equal to lambda by 2. Or the path difference is an odd integral multiple of lambda by 2. ഇതെന്താണ് നമുക്കറിയാം. That means it will produce destructive interference. ഈ ഡിസ്ട്രക്റ്റീവ് ഇൻ്റർഫറൻസ് പ്രൊഡ്യൂസ് ചെയ്യുന്നതിന് വേണ്ടിയിട്ടാണ് തിക്നെസ് ടിയെ നമ്മൾ ലാംഡ ബൈ 4 mu f എന്ന് പറയുന്ന ഒരു വാല്യൂ ആയിട്ട് എടുത്തത്. ടിയെ നമ്മൾ ലാംഡ ബൈ 4 mu f ആണ് എടുക്കുന്നതെങ്കിൽ പാത്ത് ഡിഫറൻസ് എന്ന് പറയുന്നത് ഇറ്റ് വിൽ പ്രൊഡ്യൂസ് എ ഡിസ്ട്രക്റ്റീവ് ഇൻ്റർഫറൻസ് That means if the film having a thickness T equal to lambda by 4 mu f and refractive index less than that of glass is coated on a glass, then the wave reflected from the upper surface of a film destructively interfere with the waves reflected from the lower surface of the film. Destructive interference means it will produce darkness. Such a film is known as non-reflecting film. അപ്പോൾ ആ രീതിയിൽ നമുക്കൊരു റിഫ്ലക്റ്റിവിറ്റിയെ ഇല്ലാതാക്കാൻ പറ്റും. So if a film having a thickness lambda by 4 mu f is coated, then the waves reflected from the upper surface of the film destructively interfere with the waves reflected from the lower surface of the film. So it will produce a destructive interference or darkness and hence reduces the reflectivity. Such a film is known as non-reflecting film. Now, the material of thin film is so selected that its refractive index is equal to square root of product of the refractive index of glass and air. When we are selecting the material, we are considering a condition that mu f should be equal to root of mu g into mu a. That is mu f equal to root of mu a into mu g. We know the value of mu a is 1. So, mu f equal to root mu g. Now consider the case of ground glass. The value of mu g is equal to 1.5. So mu f equal to root 1.5 equal to 1.22. For plain glass, refractive index of the glass is 1.67. So mu f equal to root 1.67, which is equal to 1.29. So this is the case of refractive index of the film. If you are using ground glass, refractive index of film should be 1.22, and if you are using film glass, it can be 1.29. The best material suitable for using non-reflective film is magnesium fluoride, MgF2, with a refractive index 1.38. So we have the value of mu a equal to 1, mu f equal to 1.38, mu g equal to 1.5. Now we have the equation for the reflectivity. So substitute in the equation of reflectivity, we will get the value as 1.3%. For a ground glass, the reflectivity in the absence of film is 4%, which is already we discussed. Now that 4% is reduced by using magnesium fluoride and the current value is 1.3%. So this technique of reducing reflectivity is known as blooming. The technique of using a non-reflecting film and reducing reflectivity is known as blooming.